Welcome everyone to the mechanics class. As you know, from last four classes, 4 to 5 classes, we are studying mechanics, the mainly the statics part. We understood the concept of equilibrium, problems on it, friction, uh, problems on frictions as well. And in the last class, we started trusses and we solved problems on it. Okay, so in today's session, what we'll do is we'll start with the homework question which I have given for the um, friction. Okay, some of you have asked me doubt for it, so we will complete it first and then um, we will move towards the trusses part. Okay, so this was the question I'm talking about, the last question from the our third class, okay, where we solve problems, and I have given 2 questions for homework and this is one of it. And a couple of students asked me about it, the solution, so I decided rather than sharing through WhatsApp, it's better to discuss in the class so things will be clear to you all. Okay, I'll read the question. A uniform bar AB, 10-meter long and weighing 280 Newton, is hinged at point B and rests on a 400 Newton block as shown in the figure. The coefficient of friction is mu, which is zero point 0.4 at all contacting surfaces. The horizontal force P required to start moving the block is. Okay, and answer is 320 Newton. I hope some of you might have already got it. For those who didn't got it, um, let's try to solve this one by one. So we'll start with the drawing free body diagram. So there are two bodies. One is the 10-meter long bar AB, and another one is the block which is 400 Newton. Let's draw them one by one. Starting with the bar. Okay. So this is point A, for example, point B. Okay. So if you look into the point B is hinged. How many reactions are there when support is hinged? How many reactions we'll have when we have a hinge support? No, Shrujana, we have two reactions. Okay, I have explained in the last class. If you have a roller support, you will have one reaction. If you have hinge support, you will have two reactions. And um, if we have fixed support, you will have two forces and one moment. Okay, so go through it. If you didn't get it, once again you can go through the recording. Okay, so here, as I said, we are having hinge support. So the whenever we are having a hinge support, we are not allowing the support to move in the right upward direction or in the horizontal direction. Okay, we are just allowing it to move. Okay, this is allowed, and these two moments are not allowed. Okay, are you following, Surjana? So that is the reason we have two reactions. Okay, whichever motion you are restricting or constraining, you can say, uh, those many reactions you will have. Okay, so here I will say horizontal reaction at B and a vertical reaction at B. Okay, consider directions randomly. If we get negative answer, we have to change the direction. Okay, keep this in mind. Okay, this is a uniform bar and weight is 280 Newton. So CG is somewhere here. Yes, anyone have any doubt? So at center we'll have the weight W acting. Let's call it as W, which is 280 Newton. And then, so if you look, the slope is given as this is 4 and this is 3. So this should be 5. But you can clearly see while giving question, the slope was given right like this. This was 4, this was 3. But the length of the bar is 10 meter, it is mentioned. Okay. So in order to get this 10, you should have to maintain the same ratio. This should be 8 and this should be 6. Are you following? We are keeping the same ratio. Uh, just multiply 4 with 8 and multiply 3 with 2. So you'll get 6 and 8. So the slope is same. We are not changing the slope. And this distance is somewhat 5 and 5. Okay. And then at the end A, what we are doing is we are putting the end A on the, let's say, a block which is of 400 Newton. So what we'll get, 400 Newton is the weight acting downwards. Normal reaction because of the ground is, let's call it as N1. Okay. But the rod is also resting on the block. Okay. So we'll have one N2 reaction here, and here also we'll have an N2 reaction upward because of the block on the rod. Okay. I hope it is clear. Okay. Similarly, you are applying force P in this direction. The coefficient of friction is mu in between all contacting surfaces. So you'll have one frictional force F1, which is in between ground and the block, and another frictional force which is in between block and the rod. Okay. Tell me if it is clear or not. Any doubt in this freebird diagram? If you get this, then there is nothing in the problem. You just have to solve it. Consider this as a coplanar concurrent system and this as a coplanar non-concurrent system. That's all. And just use equations of equilibrium to get the unknowns. In order to get the P, your aim is to calculate F1 and F2, right? Because in this figure, if you focus, what is summation of all horizontal forces? Equal to 0. If you do, you'll get P is equal to F1 plus F2. And that is what is your answer. You just need to calculate F1 and F2, add them. That is the force required in order to move the block. Okay, till this, please let me know if you have any doubt. Okay, I assume it is clear. Okay, then in order to calculate F1 and F2, what is F1 and F2? Frictional forces, and the value of frictional forces is mu times the normal reaction, right? So in order to get F1 and F2, you need to know N1 and N2. Is it clear? So how you'll get the N1 and N2, and that is nothing but by using the equations of equilibrium. So from this, if you apply summation of all vertical forces equal to 0, you will get N1 okay. What else? Minus N2 is equal to, or N1 minus N2 minus 400 equal to 0. Or rather than writing it like this, we can say N1 minus N2 is equal to 400. Okay. So this is also one equation you are getting. You got the relationship between N1 and N2. So that is what we can get if you consider the first freebird diagram, that is of the block. Okay, we got one question from Sonali here. Why N2? So when we get the normal, when we get the reaction, whenever there is the two bodies are in contact. Okay, suppose if you put one body over the another body, right? It means we are applying some weight of that first body on the second body, right? So let's call this as a first body, this is second body. So here what we are doing, we are applying the weight of the first body on the second body, right? So there will be a reaction from the second body on the first body as well. Are you following? So take a, for example, okay, you are sitting on a chair. Consider chair is as your body number one, and let's say you try to press the chair with some one of your finger or hand. Okay, you will get some uh, pain, right? Why? Because that chair is also applying um, reactive force uh, on your finger. So that is the reason. So whenever, let's say this is your this is you, or let's say consider this as second body, and if we are applying some load, or if we are applying some, let's say um, load on, if body 2 applies some load on body 1, then same reaction body 1 will also apply on the body 2. Okay, but here in this case it is inclined, so it is not the weight. So we have to calculate what will be that. Okay, so as of now I have considered it as N2, that N2 will be the reaction which is applied by the bar on the block, and same amount of reaction will be the applied by block on the rod. For every reaction there is equal and opposite reaction, right? So that is what we know, and that is what we have applied here. Okay, any other doubt? Okay, so then let's try to solve this question. uh, let's take a moments at point B, because we are not interested in the values of VB and HB. Our interest is more in calculating the N1 and N2. So if you take the reactions at point B, there is a chance that you will get the value of N2. Okay, so summation of all the moments at point B, if you calculate and equate it to 0, what will get? N2 multiplied by 8 clockwise moment minus 28 um, so one more thing I forgot to write here is frictional. This is F2. Okay, F2 we have written here, but I forgot to draw here, so F2 will be somewhere here. Okay. So 20 280 Newton. So because of this, we will have a counterclockwise reaction, and that is 280 into 4. Again, from F2 we have counterclockwise moment, so that is F2 into 6 equal to 0. Okay, so what we can get out of it, and what is F2? F2 is equal to 0.4 times N2, so 8 N2 minus, or what I can write here is 0.4 into 6 is what? 2.4. N2 is equal to 280 multiplied by 4. So from this we'll get the value of N2. N2 is equal to 280 into 4 divided by 8 minus 2.4 is 5.6. So you'll get it 200 Newton. Okay, we got the value of N2. What is the value of N1 from this? N1 is equal to 400 minus N1 is equal to N1 minus N2 is equal to 400. If N2 is 200, N1 will be 600. Okay, so you got the value of N1, you got the value of N2. So what is the value of F2? F2 is 0.4 into 200, so that is 80 Newton. And what is value of F1 from this? F1 will be 0.4 times 600, that is 240. And if you just add them, F1 plus F2, 240 plus 80 is 320. That is the final answer. Okay, very simple question. Okay, Shrujana, coming towards your doubt, why we have 2.4 N2? So from here I got 2.4 N2. What is the value of F2? F2 is mu into N2 into 6. What is value of mu? Mu is 0.6. Sorry, mu is 0.4. So 0.4 into 6 is how much? 2.4. right? So 2.4 N2. That's why I have written it like this. Is it clear? 8 N2 minus 2.4 N2 is equal to 280 minus 2 into multiply by 4. And that is how we got the value of N2. What is frictional force F1? F1 is equal to mu times N1. F2 is equal to what? Mu times N2. Okay, we got one question from Sujana. Why should we not take mu times weight for N2? Okay. See. So what I understand is uh, why we are not taking N2 as weight, right? In other words, is it correct? This is what you are saying, right? Why we are not considering uh, yeah, weight equal to N2 in this case. Okay, let me explain. If you remember, we have solved this kind of problems before. Let's take a block which is resting on a horizontal surface, and let's take another block which is resting on an inclined surface at an angle theta. Okay, so here we are applying some force P. Okay, and let's consider here also we are applying some force P. Okay, so frictional force will be in this direction. We are applying force in this direction. Okay, and now the weight of the block is in this downward direction, and because of the surface, we'll have normal reaction in the upward direction. So in this case, I agree that normal reaction is equal to weight. Why? Because summation of all vertical forces is equal to 0. That is why the normal reaction is equal to the weight of the block. Okay, is it clear till this, Srujana? And so that is why you can, in this case, you can write frictional force is equal to mu times N or mu times weight in this case. But come to the second figure. Okay, here weight is acting downward. Okay, but our coordinate system is not uh, same. Our normal reaction is in this direction. Okay, so if you remember, what is the normal reaction we consider? We consider normal reaction as W cos theta in this. Do you remember? Frictional force will be in this direction, and we have one more component of the weight that will also be in this direction, that is W sine of theta. So if you remember, we have said in this case normal reaction is not W now. Normal reaction is W cos theta. Do you remember this? Yeah. So in the same way, so it is not always that normal reaction is equal to the weight. Normal reaction sometimes equal to weight, sometimes may not. Same thing is here. I'm not putting one block exactly over the other, right? Weight of the block not completely falling on the block. Okay. Or this, let's say the block is here and rod is not standing on this block. Okay. Here, what is happening is rod is like hinge at this. So entire weight of the rod will not fall on the block. That is the reaction. The N2 will not be equal to weight. Okay. It should be something which is less than the weight. Okay, I'll come to your question, second question, Surjana. But here I'm first talking about N2. Why N2 is not equal to weight? Because entire weight of the rod is not falling on the block. You can clearly see it is hinged. So some part of it will go to the VB, okay, and some part of it will go to the N2. Because weight of the block here, if your force is equal to 0, what you will get? You get N2 plus VB equal to 280. Is it correct? Or is equal to weight? Are you following, Sujana? N2 will be equal to weight. Now, can you tell that N2 is always equal to weight in this case? No, right? Because the some part of weight will not go to will go to N2, and some part of it will go to the VB reaction at B support. If you don't put a reaction at B, an entire rod you are putting standing on, let's say the block, like this situation rod. In this situation, I agree with you that N2 will be equal to weight of the rod. Okay, is it clear till this? Now come to this free body diagram. Here, what is, if you apply summation of all vertical forces, what will get? N1 minus N2 minus 400 equal to 0. So N1 minus N2 is equal to 400. See, if you don't put any, let's take a bar or let's take a block. I'm not putting anything on block. So in this case, this W will be equal to N2, N1, let's say. Okay. I'm talking about your second question now. That is in for the horizontal block also, we have not considered the weight. Okay. In this case, I have a single block, nothing kept on it. I will take block summation of all vertical forces equal to 0. In that case, W is equal to N. It is not always W is equal to N. If I put something on it, okay, let's say block 1 and block 2. And now if I draw the free body diagram of block 1, we have one reaction coming from block 2, that is, let's call N2. We have one reaction coming from ground, that is N1, and then weight. Okay, so weight plus N, or let's say weight plus N2 is equal to N1, we can say, or N1 minus, yeah, is equal to N1. So in this case, the N1 reaction because of the ground should not be just equal to weight. It will be weight plus some other reaction acting on it. Are you following? See, if you put a chair on a ground, how much reaction will chair will get? Whatever is the weight of the chair, that much reaction the ground will give to the chair. Now you are sitting on that chair. Then how can you uh, still say that reaction by ground should be equal to the weight of the chair only, and it should not consider your weight? Are you following what I'm saying, Sujana? Good. So that is the reason. Don't keep in your mind that weight is equal to normal reaction is equal to weight. That if that is in your mind, clear that concept first. That is not the case. Okay, you have to apply the equations of the equilibrium, and then you can decide whether normal reaction is equal to weight or not. In some cases it will be, in some cases it may not be. Okay. Okay, any other doubt in this question? So I'll come to your question. I'll first answer the Sujana's question. It should be 280 multiplied by 5. What is 280 multiplied by 5? Are you talking about the reaction moment? No. What is moment? Moment is the force into perpendicular distance. Moment is force into perpendicular distance. Okay, so what is the perpendicular distance? Perpendicular distance is 4, and that is why 280 multiplied by 4 is considered. Okay, I hope it is clear your doubt, Sujana. Let's come back to Ranjan's question. How we have taken the moment along B. Okay, let me explain you in the fresh slide, Ranjan. So this is point B and this is point A. We got a horizontal reaction at B. We got a vertical reaction at B. we got N2 here, we got F2 here, and we got okay, let me share and share the screen again if it is frozen. So give me a minute. Okay, I hope it is visible now. Wait. Ranjan, is it clear till this? Okay, then let's take moment about point B. Do you agree that moment at point B, if we take the moment because of HB and VB is 0? Moment because of the forces HB and VB is 0 because it's passing through that point. Yeah. Now take moment about B. So only how many forces which will create the moment, that is N2, F2, and weight. So this distance, if you see, it was 4. Let me show you if it is, if you forget, it was 4. Correct? It is at center, so this should be 4 and this should be 4. Okay, so let me come there to that slide. So moment because the weight is W into 4. Okay, minus W into 4. Why? Because it's a counterclockwise moment. Then because of the force F2 also we have counterclockwise moment, that is minus F2 into, what was the height of this? The height of this was 6, so minus F2 into 6. Okay, and because of the N2 force we have clockwise moment, and that is N2 into perpendicular distance was 8, so N2 into 8 is clockwise, and that is equal to 0. Okay, so is this what you are asking, or you want me to completely calculate N2? Is it clear till this or not? Yeah, you just have to solve this, you will get the N2. Okay, good. We got any other question? Dharmesh, is it? Can you see the screen? Any doubt you have? Okay, feel free to ask if you have any doubt. So you should try this question. Okay, I hope at least the second last question you might have solved it. The answer was 8.83. Okay, and if you still have any doubt, maybe in the next session we will take it up. Okay, feel free to reach out to me if you still if you are not able to get that answer. We can either discuss on WhatsApp or in the next session I will take that question. Okay, but these things are clear to you because this should be clear to you because we have done this and you should be capable of solving it. Okay, the main, there is not much theoretical part or any in this. This is not a theory subject. Okay, it is conceptual subject. You should just understand how to draw the free body diagram and apply the equation of equilibrium. The 90% of the work you will complete when you are able to draw the free body diagram, and that comes with the practice, or that comes with the handling different kind of problems. So that is the reason I am giving you variety of problems. Okay, so you should know first what is the how to draw the free body diagram. If you are able to draw the free body diagram, the 80% of the statics part, like, you understood, because after drawing free body diagram there is nothing, there is just a mathematics. We are apply summation of horizontal forces equal to 0, vertical forces equal to 0, summation of moments equal to 0, and get the answer. That's all. Okay, so that comes in your 20%. Calculate the angle. How we calculate angle? just summation of all vertical forces divided by summation of horizontal surface is equal to tan of theta. Okay, how to calculate the reaction? Under root of summation of horizontal forces plus vertical forces, we'll get the reaction. So there is nothing much, because in the, let's say, the later part after drawing the free body diagram, it is just a simple mathematics. Apply the equations of equilibrium and solve it. Main thing you should know is how to draw the diagram. If you make mistakes, like if you forget to write n2 here, or if you forget to draw the some for let's say some frictional force, and are not able to properly take the moments, then that's all. Like you're done the full mistake in the problem, and you'll get wrong answer. So focus on variety of problems, I would say, and try to draw the free body diagrams as much as possible. Okay, then only you will be able to solve that question in exam. Okay. Yes, someone has raised your hand. If you have any doubt, feel free to ask. Okay, so if it is clear, then I'll come back to the part of trusses. So in trusses, if you remember in the last class, what we have studied is how the truss structure looks like. What are the let's say method of joint, basically. How by using the method of joints we can solve the problems, and we have also studied uh, what should be the relationship between number of joints and number of members in order to have a stable structure, unstable structure, or let's say redundant structure. Okay, so in today's session we will again study the um, analysis of stresses, but now it is with the method of sections. Okay, so write down heading method of sections. Okay, method of sections. Let me draw the figure. Okay, yeah, so let's take this example. We have w1, w2. Okay, w3. We'll try to first understand the theoretical background, and then we'll jump into the questions. Okay. Mhm. So assume this as your um, the truss structure. Okay. Now, how to solve this? Okay. Generally, if a simple figure comes like just a single truss or just two trusses like this, so I would suggest in that case use the method of joints. Okay, but whenever a bigger truss comes like this, then if you go on using the method of joints, you have to, let's say, in order to get the force in this member, you have to solve this joint. First of all, you take this joint, then this joint you have to solve, then this joint. So you'll do a lot of calculations in that. Okay, and similarly, if truss is more bigger than this, then it is not, let's say, a good way to use the method of joints, because you will spend a lot of time uh, analyzing different joints together, and it will be waste of your time. So in that situation, you have to use the method of sections. Okay. So what are the steps whenever we have to follow whenever we are solving the truss problem, a bigger truss problem, by using the method of sections? So write down first step, step number 1. Determine the reactions at the support, okay, by using equations of equilibrium. What are the equations of equilibrium? Summation of all horizontal forces equal to 0, summation of all vertical forces equal to 0, summation of all the moments equal to 0. Okay, so apply this equations of equilibrium and get the values of the reaction, so at the support. So here, for example, we have support Ra and Rb. That is what we are saying here. Okay, get the values of Ra and Rb. Step 2 is cut the section passing through the member in which force is desired to be. Okay, force is desired to be calculated, and draw the free body diagram of either side. And draw the free body diagram of either side. Okay, we got a question from Dharmesh. Sir, there will be 2 reactions at A. Okay, Dharmesh, I'll draw the second reaction also, H A, but the value of H is 0 because we don't have any horizontal force. Can you see any horizontal force in this structure? So if you take summation of all horizontal forces equal to 0, what you will get? HA equal to 0, right? So there is no need to draw it. Whenever you should keep in your mind that whenever we have a hinge support, you will have 2 reactions, and whenever we have roller support, you will have 1 reaction. But that doesn't mean always you have the 2 reactions. Okay, you have to apply your common sense there. I don't have horizontal force any on the this, so I'll not get any horizontal reaction, right? Yeah. Okay. Coming towards step 2, cut the section passing through the member in which force is desired to be calculated and draw the free body diagram of either side. Okay, so for example, you are interested in finding the reaction, finding the load, okay, for force in the HE, let's say, member. This to cut the section passing through the member. So you have to cut the section something like this. Okay, so this is your cutting section, and because of that you will break the truss into 2 parts. But you have to keep one thing in mind while you are cutting. Okay, the cut section must not pass through more than 3 member. Must not pass through more than 3 member. Okay. So if I draw it like this, something like this, then it is incorrect. Okay, because how many members it is passing? 1, 2, 3, 4, 5. Okay, so even let's say if I draw something like this, 1 2 3 4 5, that is also incorrect. So you have to cut in a such a way that you will have, let's say you will cut the section where it will not pass through more than 3 members. Okay, is it clear, the step 2? And then what you have to do is you have to draw the free body diagram of the, or you have to, let's say, draw the FBD of either side. Okay, so let's take you, in this case you are taking only left hand side, so how it will look like, uh, just give me a minute. I will let me draw it on the next slide. So basically okay, F D E, then W2, here we have W1, here we have VA, let's call it as L1 L2. Okay, there you have L1 L2 are, let's say, these lengths. Then what else is remain? HE, this was A, this was C, this was G, this was D, and this was H. So we have one EHE. Okay, force in HE member, total force here, that is force in HI member. Okay, are you following? This is the free body diagram of either side. Free body diagram of left side, I would say. So it's your choice. Either you can take right hand side free body diagram or left hand side free body diagram. Okay, so it's a similar, just let's say directions will change. Okay, so here I have taken the left side as it is and drawn the free body diagram. Is it clear till step number 2? Any doubt? Feel free to ask. Okay, the last step is adapt equations of equilibrium on the free body diagram, or let's say apply equations, equilibrium equations on the free body diagram, uh, and find the required unknown force. Okay, so again same equations of equilibrium, summation of all horizontal forces equal to 0, summation of all vertical forces equal to 0, summation of moments about z axis are 0. This is what you have to apply and get the unknown force. Okay, so here FHE is what we are interested in. This is what we are interested in. Okay, so then you have to apply the, let's say, your understanding on it and get the value. Okay, is it clear till this? Anyone have any doubt? At least the process. Then I'll give some questions to you to solve this. Write down. Okay, we got one question here from. Okay, we got one question um, here from Ganesh. Yeah, W1, W2, W3 can be different. Okay, Ganesh, it's not necessary that they should be same. Any one of them can be, let's say, bigger or smaller. So if W3 is bigger, what is your opinion on the reactions, RA and RB? Okay, automatically will take it into the account while calculating the reactions at A, right? You know, like how you'll calculate reaction at A? Let's say you'll say uh, W1 plus W2 plus W3 is equal to RA plus RB, you'll say. And then you will apply, let's say, you take a moment about any point and equate it to zero, you will get the um, you'll get the reaction, right? So basically, higher the W3, higher will be RB reactions at B. So ultimately, which if even though you are applying higher load at any joint, it will consider in the, let's say, it will get automatically considered in the reactions. Okay, what I'm trying to explain you here is the logic of drawing the figure diagram of either side means even if you consider the right hand side section or the left hand side section, whatever load will be in this, let's say, HE member will be same as that of if you consider the right hand side section. Okay, so that is the ultimate logic you should know. Okay, even if the weights are different, with if W3 is higher, let's say larger or bigger than the W1 and W2, that's not an issue. Automatically that will consider when in the first step itself when we calculate the reaction. Okay, because for whatever weights you are applying, there will be opposing equal reactions, right? So we are anyway considering it. So it doesn't matter which W is um, higher or lower. Okay, you can still apply the method of joints, okay, previously, but you know that takes time, right? Whenever you have bigger truss, in order to calculate this, what you have to do is you have to calculate this, then you have to calculate this. So um, in short, what you have to do is you have to consider this first joint, let's say first joint, second joint, and third joint. Three joints you will consider in order to solve the problem. Okay, and that is, let's say, very tedious task, right? So that is the reason an alternative method for bigger truss is developed, and this will be very helpful and comparatively easier. Let me give one question so the things will be clear to you. Determine the force in the member BC. Truss shown in the figure. Mhm. Okay, so you are supposed to calculate the force in the member BC. Okay, all the inputs are given to you. We have supports at the A and B, A and G. A, B, C, D, E, F, G are the joints. Okay, the joint A and E are separated by 5 meter. E and F are is separated by 5, and F and G is separated by 5 meter. And between D and G, we have 6 meter distance. Okay, solve this and tell me the answer. Okay, I'll give you 2 minutes of time. You know the process. Apply the logic and solve it. Anyone solve this? Okay, um, let me help you out. First step, is what? Let me just go back here. Um, Determine the support reactions by using equations of equilibrium. Okay, so if you apply that to this question, VA, so we have VA and HA here and VG here. So VA plus VG will be equal to 100 plus 200. Okay, so VA plus VG is equal to 300 according to the equation of equilibrium. Summation of all vertical forces equal to 0. Okay, and applying summation of all horizontal forces equal to 0. We don't have any other horizontal force, so HA here is also 0. Okay. Mm, no, Srijana. Navya, no. Little bit wrong. You are looks like more closer to the answer, but um, slightly incorrect. Okay, you have answered VA and VG. Yes, VA VG is correct. Sujana, VA is 133.33 and VG is 166.66. Yeah, can you find the force in the member BC? Force in the member BC, Navya, no, it's incorrect. So this is the first step. What is the second step we have to do? Cut the member in which force is desired to be calculated. Okay. Or let's say cut the section passing through the member in which force is desired to be calculated and draw the free body diagram of either side. Make sure that cut section must not pass through more than 3 members. So here we are interested in the uh, let's say force in the member BC. So I would cut it like this. Okay, this is our cut section. So if I want to draw the free body diagram of either side, let's draw it on the left hand side. How it will look like is this. (100 Newton) A B E. Okay. Here also we have one force, that is FBC, FEC, FEF. Okay. This is 5, height is 6. Okay. Is it clear till this? Any doubt till this? We have done the first step number 1. We have done the step number 2. Feel free to ask if you have any doubt. And here I'll draw the VA directly. Yeah. Okay. This is a free body diagram of the uh, either side. So here I have taken the left hand side into the consideration. Now, third step, apply the equation of equilibrium and get the answer. So you want to get the force in the member. This is your requirement. If you take moment about point E, automatically the moment because of the FEC, FEF and 100 Newton force will become 0. So that will makes the problem easier. So force in the member BC multiply by 6. Okay, if you take summation of all the moments at point E and equate it to 0, FBC multiply by 6 plus VA multiply by 5 equal to 0. Okay, so VA, so keep this as equation number 1, and once we have the value of VA, we will directly get the value of FBC. Okay, now come to the come to this equation. Let's call this as equation 1. This has equation number 2. Come to the equation number 1. How is there any other way to calculate V and VB? Yes, take the moments. Or let me just rub this. I'll do this in the next slide, and here I'll just calculate V and VG for you. If you take the moments about point G, summation of all the moments about point G and equate it to 0, VA multiply by 15 minus 100 multiply by 10 minus 200 multiply by 5, okay, is equal to 0. So VA is equal to 1000 10,000, yeah, 1000 plus 1000, 2000, 2000 divided by 15, 133.33. Okay, Newton is the force. This is your VA, and VG is equal to 166.66. And now, yes, Sujana, your answer is correct. So we got V and VG, and then coming towards step 2 and taking moment about point E, summation of all moments at point E is equal to 0. So it is VA multiplied by 6 or 5. VA multiplied by 5 plus FBC multiplied by 6 equal to 0. So VA we know that is 133.33 Newton into 5 equal to FBC minus, make it here, and divided by 6. The minus sign indicates the direction which we have considered is incorrect. It should be something like this. Okay, now you just relook into it. It will create a negative here sign. You will take a positive sign here. Okay, and FBC will be equal to 111.10. Okay, that is the answer. Okay, because the upper side is under compression, so the direction which we have considered was incorrect. So you can correct it, and like this it will look. Yeah. So 111.10 Newton is the correct answer. Yeah. So don't get confused if your answer get positive or negative. The answer is always positive. Okay, such just you have to check whether it is in compression and or tension. Okay, upper section will be under compression, lower section will be under tension. Okay, as I explained before. So even if you did get a negative answer, that doesn't mean it is wrong. Okay, the only thing is that direction which you have considered is incorrect, and you can correct it. Okay, that's all. Any doubt till this? Is it clear to you all how to use the method of section and solve the problem? Yeah, if it is clear, then I'll give you one more question to solve. Force in the member AB of the truss shown below. Draw this figure. And this is the member AB. Okay, you can rename the other members if you want. 3 kilonewton. And there is no other loading in this. Okay. Uh, okay, this is 1.5 meter. So everything is 1.5 meter. Height is also 1.5 meter. So consider this figure and solve it. Okay. I'll give you 5 minutes break in this. You have to solve this question and um, post your answer. Okay. I'll just come back in 5 minutes. If you have, if you think any input is missing, you can just ping me and solve this. But everything is given to you. You should be able to solve. Yeah. So I'm back. Let's continue this problem. Some of you have already solved it. If you are not solved, then I'll help you out here now. So you can clearly see this figure is symmetric, right? So what is the reaction at these two supports? The reaction at these supports are like 25 Newton and 25 kilonewton and 25 kilonewton. You don't have to calculate even. Symmetric figure. At the center, if you are applying the load, it is equally distributed. That is 25 kilonewton. Okay. Now we are interested in the force in the member AB. Let's cut the section passing through the member in which force is desired to be calculated. Okay. And let's say this section is XX, and draw the free body diagram of either side. So how it will look like is this. Okay, this is FAB. We have this one force, and then we have one force in this direction, and we have one reaction here, that is 25 kilonewton. Okay, figure is symmetric, so 25 25 sorry 45 45 degree angles are this. So what is mm, there which we can calculate is you are interested in this FAB, right? um, yep. So where you can take the moments. If you take the moment at point, let's say this point, this particular point, let's um, call it as maybe you can take at this moment, I will call it as, let's say, G point. So the only moment it will be 25 into this 1.5, and that will be equal to FAB cos of 45. Okay, so FAB cos of 45 into 1.5, that is equal to 25 into 1.5. Okay, that is what we can take if you take moment about summation of all moments about point G equal to 0. If you take, you'll get it like this. And now 1.5 1.5 will get cancelled. Cos of 45 is 1 by root 2. So FAB is equal to 25 root 2. Okay, and that is 35.3 something. Okay, kilonewton. Okay, is it simple, clear? Anyone have any doubt in this? Okay, feel free to ask if you have any doubt. Okay, then let me see if we have any other points today. Okay, that's all we have for trusses. Okay, um, the till this, if you have any general doubt, we can discuss. We have some time. Otherwise, I would like to give an introduction of dynamics. The virtual work topic we'll study at the end. Okay, because without that as well, we can solve the problem. So we can keep it at the end. and we will be studying it, but at the end we'll study. Okay. If you have any doubt, you can ask me now in the statics, um, the portion which we have studied. Um, Otherwise, yes, Srujana, I can share you. So if you don't have questions from previous year, or maybe in the next session, what I'll do, I'll collect some good questions and give you for homework. Okay, you can try. Is it okay? So yeah, so we'll follow it. In today's session, I don't have any homework question for you, uh, because we have solved many questions in the last session of trusses, and I will collect if you want more for your practice. But in the meantime, you can also parallelly go through the questions from, let's say, online test series or previous year papers. Okay, uh, you will realize that whatever we are studying till now, at least for static part now, is 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 you can apply there and you can solve it. Okay, yeah. So I'll collect some questions from statics and give it to you in the next class for homework. You can try it. Yeah. So what I'll do is I'll give one small introduction about the dynamics, what we are going to study in this topic. Okay, write down heading dynamics. So what is dynamics? Dynamics is the study of motion of a particle or a rigid body. Study of motion of a rigid body with respect to time due to application of external forces. Okay, due to application of external force. This is how you can define the dynamics. Now, let's say this dynamics in the first class itself, I have explained you. It is divided into two parts. One is kinematics part and kinetics part. Okay, what is kinematics? Kinematics is study of motion of a rigid body without considering the forces. This is without considering the forces. And this is considering the forces. Okay, so we'll first focus on the kinematics part where we are not talking about the forces. We'll just focus on displacement, distance, displacement, velocity, acceleration. Okay, so we'll be studying the uh, motion of a rigid body with respect to time due to application of external forces, considering the without considering the extra, let's say, external forces which is causing the motion. Okay, so we'll be only dealing with the velocity, displacement, and acceleration, deceleration, these kind of terms. Okay, can you tell me what is the difference between the distance and displacement? Anyone? Displacement versus distance versus displacement. Similarly, speed versus velocity. Yes, correct, Srijana. Distance is a scalar quantity, whereas displacement is a vector quantity. Okay, so we are passing from point A to point B. If this straight line distance in between point A to point B is called as a displacement. Okay, this is vector quantity, have particular direction. Whereas, let's say you can go to point from a point to point B with like this as well. Okay, let's say something like this. Okay, and you can call it as a distance. It can be anything. So this is also, you can take any route from A to B. It is a scalar quantity. Okay. So speed and velocity is same. Speed is again the scalar quantity, which is distance divided by time. So for example, in Google Map, you're going from point 1 to point 2, with which is at a particular distance, and you have to reach there in particular, let's say, um, time. Let's say in 1 hour, for example. Then at what speed you should be going, you can find by using, let's say, distance divided by time relation. Okay, so speed is equal to distance divided by time. In the same way, velocity is the vector quantity, and you will have velocity vector, that is vxi plus vyj plus vzk. Okay, so this is the velocity, direction of velocity. You can um, define if it is only in x direction, vy vz will be 0, vxy will be the only velocity component. So it is basically change in displacement with respect to time. You can call it as a um, velocity. Okay, displacement divided by time. Okay, how the displacement is changing with respect to time, you can say it as um, respect to time, you can call it as a velocity. Okay, what about the acceleration? The acceleration can be, let me go to the next slide to explain it. The acceleration can be, let's say, constant acceleration, or maybe variable acceleration as well. Can you tell me the situation when we have constant acceleration? Can you explain the motion like where the acceleration is constant? Any general example? Simplest example is any motion under the gravity. Okay, so if you, let's say, a particle is falling from certain height under the, let's say, problem. Okay, so all gravity related problems, you can say, are the um, let's say, the constant acceleration problems. Ganesh, if your velocity is not changing, means acceleration is 0, right? What is acceleration? See, how you'll calculate velocity? Velocity is ds by dt, and how you will calculate acceleration is dv by dt, right? This acceleration you will calculate. Now, if your velocity is not changing, then your acceleration is 0, right? So that situation is not like a constant acceleration. So what I would say is, whatever, let's say, uh, mainly the simplest examples are like motion under gravity, gravity under gravity motion, under gravity motions of particle. Okay, and what are the variable acceleration problems? Let's say uh, variable acceleration is like, you are, let's say, riding a bike, okay, and going let's say in the Bangalore traffic, and um, from point A to point B. At some point you will accelerate, at some point you will decelerate, and your acceleration will vary um, throughout your journey, right? You are at some uh, so it is not a constant acceleration, like I'd say from one point to the another point in general, our day-to-day life of driving. So that could be an example of, you can say, a variable acceleration. Okay, so I would like to just introduce you these 2 points that you should keep in mind, that some motions can be, or some motions are with the under gravity, so you should treat them as a constant acceleration problems, and some motions with a variable acceleration problems. Okay, depending on the problem which you are focusing, understand whether the motion is with a constant acceleration or with the variable acceleration. Okay, any doubt? Uh, I assume this basics you know, uh, and if this is clear, then let's say mm, we can proceed uh, for the further discussion. So whenever I am saying constant acceleration, okay, what are the constant acceleration formulas rather than problems? V is equal to u plus at. Half at square. Okay, so these are the, let's say, um, let's say the formulas which we'll be using when it comes to the constant acceleration problem. Do you know them? You are aware of them, right? Maybe from in class 8th or 10th, you are studying this, but you should know that these are applicable only when your acceleration is constant. You should not apply them when let's say you have the variable acceleration. Okay, um, if you want the derivations of this, I can give you in the next class, so I'll derive it in the next class. Okay, but as of now I will solve some questions, very simple questions, where I would want you to, let's say, focus on them and understand whether it is a simple acceleration or a variable acceleration problems, and solve them. Okay, so really very simple questions I'll give to you today, and in the next session we'll increase the, let's say, complexity of the questions. Take a first question: velocity time relationship of particle is given by x dot is equal to half of ct square, okay, where c is equal to 8 meters per second cube. Mhm. Determine the displacement at t is equal to 3 seconds if there was no initial displacement. Okay, solve this question. Very simple. Okay, nothing big in this. Velocity time relationship of a particle is given by x dot is equal to half of ct square. S is given, and what you have to calculate is determine the displacement at t is equal to 3 seconds. The value of c is given, c is equal to 8, and they also mentioned that if there was no initial displacement. Okay, apply your understanding and solve this question. Okay, this you have to type the answer here, so I'll not tell the options. Yes, Dharmesh, correct. 36 is the correct answer. You know that velocity is this change in displacement with respect to time. That is half of ct square. The value of c is 8. So you can keep it as it is if you want as of now, ct square. And what they are asking is the displacement. So s they are asking that will be integration on both the sides with respect to t, half of ct cube divided by 3 plus k. Okay, so s is equal to 1 by 6 ct cube plus k, and they have given at t is equal to 0, s is equal to 0. So 0 is equal to 1 by 6 c into 0 plus k. This implies k is also equal to 0. Okay, so s is equal to 1 by 6 ct cube is the final um, answer, and our final equation. C is 8 and time is what they are asking is 3. At 3 seconds, what is the displacement? So if you further solve it, you will get it as 36. Okay, yeah, most of you answered it correctly. Okay. Next question. The time variation of the position of particle in rectilinear motion is given by x is equal to 2t cube plus t square plus 2t. If v is equal to v is the velocity and a is acceleration of particle in, if v is the in constant unit, the motion started with. Okay, Okay, v is equal to 0, a is equal to 0, v is equal to 0, a is equal to 2, v is equal to 2, a is equal to 0, v is equal to 2, a is equal to 2. Okay, solve this question. The time variation of position of particle in a rectilinear motion is given by x is equal to 2t cube plus t square plus 2t. If v is the velocity and the a is the acceleration of the particle in constant unit, the motion started with. Yes, option D is correct here, Rudrani. V is equal to 2 and acceleration is equal to 2. It's very simple. Let's solve it. V is equal to, so x is given, that is 2t cube plus t square plus 2t. So dx by dt is velocity, 6t square plus 2t, and acceleration will be dv by dt, and that is 12t plus 2. Okay, and this implies v at x is at t is equal to 0 is what? Um, sorry, plus 2 is 0 plus 0 plus 2, and acceleration at t is equal to 0 is 0 plus 2. Okay, so 2 is the correct answer. Okay, acceleration is 2 and velocity is 2. So option D is correct. Yeah, any doubt in this? Very simple questions. Okay, basics. Let me give you one more. A particle moves along a straight line with an acceleration described by equation A is equal to 4t square minus 2, where A is in meter per second square and T is in second. Okay. Okay, where is and T is in second. When T is equal to 0, the particle is located 2 meter to the left of the origin, comma, when T is equal to 2 seconds, the particle is located 20 meter to the left of the origin. Okay, full stop. The position vector sorry, the position of particle when t is equal to 4 seconds is. Okay, you type the answer. Okay, I'll repeat the question. Listen carefully and solve it. A particle moves along a straight line with an acceleration described by equation a is equal to 4t square minus 2, where a is in meters per second and t is in second. When t is equal to 0, particle is located at 2 meters to the left of the origin, and when t is equal to 2 seconds, the particle is located at 20 meters to the left of the origin. The position of the particle when t is equal to 4 seconds each. Solve this and tell me your answer. Okay, tell me the answer. So all these problems which you are solving are variable acceleration. You can clearly see acceleration is time dependent. Okay. I have not started any problem on constant acceleration yet. First we'll focus on the variable acceleration. You should know. So here the only thing you have to know is the change in displacement is velocity, change in velocity is acceleration. That's all. So only differentiation and integration you should know. Apart from that, nothing is required. No, in Sujana, Dharmesh, try to solve a bit more. Okay, let me explain you what they are saying. When t is equal to 0, okay, the particle is somewhere here, minus 2. Okay, this is our origin, this x-axis, y-axis. Somewhere here is the particle. And when t is equal to, at t is equal to 0. And when particle is, let's say here, minus 20 meter, when, let's say at t is equal to 2 seconds. And when what they're asking now is at t is equal to 4 seconds, where the particle will be. Okay, this is what in short they are asking. Yes, 28.6 correct, Navya. Your answer is correct. So let's solve this. Let's try to solve this. I'll go to the next slide. What they have given is a is equal to 4t square minus 2. They have mentioned at t is equal to 0. So at t is equal to 0, what is acceleration? Acceleration is equal to minus 2, right? So it is basically the deceleration. Okay. Change in velocity with respect to time is acceleration, and you can write it as 4t square minus 2. Okay. So velocity can be written as integration of 4t square minus 2, that is 4t cubed by 3 minus 2t plus some constant. Okay. what they have mentioned is when the t is equal to 0, particle is located at 2 meters. So basically, um, it was there uh, at the rest. So at t is equal, so or at you can say not rest. Whenever a particle is at, let's say, t is equal to 0, it was at -2 location. So let's keep as of now the at t is equal to 0, the velocity will be c. Okay, velocity is constant, whatever is the proportionality constant. Okay, and again, dv, or let's say v is equal to what? Change in displacement with respect to time. Okay, so you can bring out displacement here as and this is our 4t cube by 3 minus 2t plus c. So x can be written as t raised to the power 4 by 4. 4 will get cancelled, so t raised to the power 4 by 3 minus 2t square by 2. 2 will get cancelled, plus c1t, let's call it as c1, plus c2. Okay, so this is our displacement, and now from here we apply whatever the given data they have given. So at t is equal to 0, x is equal to 2 meters. Okay, for example, though the distance is on left hand side, that doesn't mean negative displacement, right? Displacement is obviously 2 meters. Okay, so what you will get here is, if you put x t is equal to 0, c2 is equal to 2, you will get. Okay, or let's see how it goes by this way. And then now at x is equal to, let's say, or at t is equal to 2 seconds, x is equal to 20. So I think, yeah, you have to consider it negative because it's a displacement. So minus 20 has to be equal to 16 by 3 minus t square is 4 plus c1 is what we have to calculate, and into 2 plus minus 2. Okay, and this will give you, I think, how much? Should be minus 16 minus 16 by 3. Okay, so c1 should be equal to something around minus 9.66. Just check it. Yeah, thank you, Nove. 6.67 you will get. And then what they are asking is the value of x when the position is, when time is 4 seconds. So t raised to the power 4 is 16 by 3. No, 4 raised to the power 4 by 3 minus t square is 16 plus c1 is minus 9.67, t is 4 minus c2 is 2, and solve it to get 28.69. Okay, yeah, correct me if I had done some many mistake here, numerical mistake, but I think this should be correct. 4 cube by 3 minus 16 plus c1 is minus 9.67 into 4 plus 0. Yeah, correct. Okay, Kanishk is asking, c1 value is different if we use at t0 as -2 and at s at T2 is 20. No, I think you should not consider it. You should consider minus 20. Sorry, yeah. Or let's keep it 20. Then see, only thing is in calculation you are putting it as minus 20. Okay. So you are considering this as a minus 2. You have to consider this as this as well as minus 20. Okay. Dharmesh, let me just go to the question here again. A particle moves along the straight line with an acceleration described by an equation. When A is where A is in meters per second square and T is in when T is 0, the particle is located at 2 meter to the left of the origin. They are not saying that um, the velocity of the particle at that point is 0. Okay, Dharmesh, they are not saying the velocity of the particle at let's say um, uh, at that point is 0, or let's say they have even not given us the data. Already particle is moving. They are saying the particle is moving with an acceleration like this, and let's say at time 0 the particle is located at particular distance. At point at time 2 the particle is at certain location. So at let's say 4, it will be at what location? That's how we are calculating it. Here it is nothing like starting from rest and all. Okay, give me another question. Let me give you another question. Mm, Variable acceleration again. Mm, Or let me give you two homework questions. You try it, and if you fail, I will explain you in the next class again. Okay. The velocity of particle moving along x-axis is ax cubed or x square 6x, where v is in meters per second and x is in meter. Uh, v is constant. If k is equal to 1, the value of if k is equal to 1, the value of acceleration when x is equal to 2 meter would be. Okay. Here the answer is 8 meter per second square. Okay. I'll repeat the question. The velocity of a particle moving along x-axis is v is equal to kx cube minus 4x square plus 6x, where v is in meters per second and x is in meter, and k is a constant. If k is equal to 1, the velocity, the value of acceleration when x is equal to 2 meters would be. Okay. Solve this. You should get 8 meter per second square as answer. This is your homework question. You tried. Another homework question I would like to give is this. The motion of particle in, in rectilinear motion is defined by E is equal to 6 root V. T is equal to 2 seconds. V is equal to 36 meter per second. and S is equal to 30 meters. The value of S at t is equal to 3 seconds is okay, and here the answer is 87. Okay, take these two questions for your homework and tell me in the next class if you are or the before next class if you are able to if you are not able to solve it, then I'll take up in the next class. Okay, but I think we have solved previously now 3-4 questions, and with that you should be able to solve these two. Okay, a is equal to 6 times root v. Sonali, a is equal to 6 times root v. 6 into root v is the acceleration, and that is 6 times root v. So basically dv by dt is equal to 6 root v. I'm even giving you a hint to solve. Okay, with this you can proceed. Okay, so that's all we have for today. We are at the end of the session. In the next class, what we are going to do is I'll give the we'll start some constant acceleration problems. I'll give the derivation of the equation of the motions and some homework questions from the statics as well. Okay, so that's all we have for today. Let me know if you have any doubt till this. If not, we'll close the session. Okay. If no doubt, then thank you all for joining this class, and let's meet again in the next. Bye. Have a good Sunday to all.